So you're looking to build a machine for local AI, right? And you've probably hit this wall. Do you go for a beast of a card from the last generation or something brand new and super efficient? Well, today we're going to settle that debate. It's the RTX 4060 versus the RTX 3080. Let's get into it. Okay, so let's tackle the big question right away. I mean, your first instinct is probably to just grab the newest piece of tech, right? A 40 series card has to be better than a 30 series. But, when we're talking about AI, the answer is, well, it's not that simple at all. And here's why it's a dilemma. See, AI workloads are just different. When you're running something like Stable Diffusion to make images, or you're fine-tuning a language model, which is basically just teaching it on your own stuff, you're pushing the GPU in a totally different way than you would with a video game. We're not chasing frames per second here. Nope. It's all about memory, how fast you can move data, and these little specialized bits of hardware. All right, let's bring out the contenders. And think of these less as just two graphics cards and more like two different fighters with totally different styles. In this corner, we've got Ampere. That's the architecture behind the RTX 3080, and it is a pure brawler. All raw power, all computational muscle. And in the other corner, you have Ada Lovelace, the brains behind the RTX 4060, built from the ground up for efficiency and smart modern features. And this slide really breaks down their fighting styles. The 3080, it's all about brute force. We're talking massive compute power and this huge data pipe, which is exactly what you need for the heavy lifting, like training a model from scratch. The 4060, on the other hand, is the technical boxer. It's a specialist in what we call inference, which is just a fancy word for running a model that's already been trained. And it does this while barely breaking a sweat, just sipping power. Okay, so to really figure out which one is the right choice for you, we need to cut through all the marketing noise. Let's focus on the three numbers, the three key specs that really truly matter for AI work. First up, and honestly, this is the big one, VRAM. Think of VRAM as the disk space your AI has to work on. And as you can see, this is where things get interesting. The 8 gigabytes on the 4060, well, that can be a real problem. It's a small disk. The 10 or even 12 gigabytes on the 3080 gives you so much more room to breathe. It's the difference between everything fitting comfortably and your performance just falling off a cliff because the model is too big. All right, next up, memory bandwidth. So if VRAM is the disk, bandwidth is the highway getting data to and from that disk. And whoa, just look at this chart. It perfectly shows the 3080's raw power advantage. Its highway is almost 3 times wider. That means it can just fire data at its core so much faster. And believe me, when you're trying to shovel huge data sets into a model during training, that is absolutely critical. But hold on, don't count the 4060 out just yet. It has a secret weapon, a real ace up its sleeve, and that's its modern architecture. NVIDIA says it right here. It's built around these 4th-gen tensor cores. Now, these are basically specialized little calculators just for AI math. And this new generation, it comes with a game-changing feature. And that feature is something called FP8 support. Now, what does that mean in plain English? Well, think of it like this. It's a new, super compact way to write down numbers. For the GPU, this means it can effectively slice a model's memory usage in half when you're just running it for inference. This is how the 4060 can punch way, way above its weight class in VRAM, assuming, of course, the software you're using can actually take advantage of it. And the 4060's other advantages? They're all about being smart and efficient. On the left, you see it has a massive L2 cache. That's like a super fast little notepad right next to the processor, so it doesn't have to keep going back to that slower VRAM. And then on the right, just look at that power draw. I mean, it's incredible. 115 watts versus over 300 for the 3080. That's not just about your electricity bill. It means less heat, a smaller power supply, and yeah, you could literally run your AI jobs 3 times as long for the same cost. Okay, so we've got the brawler versus the technical boxer. Raw power versus smart efficiency. But how does this all translate when you actually try to do something? Let's put these two head-to-head on some of the most common AI tasks you'll be running at home. But before we dive into the specific tasks, let's just do a quick tale of the tape. This table really tells the whole story at a glance, doesn't it? The 3080 is all about that massive VRAM and bandwidth. The 4060? It's all in on those 4th-gen cores and that jaw-droppingly low power usage. All right, let's see how they do. Okay, round 1. This is probably the one most of you are here for, Stable Diffusion. You want to make incredible AI art. So which card is going to be your creative partner? And for Stable Diffusion, well, the verdict is pretty clear. In this arena, VRAM is king, period. The RTX 3080, especially that 12GB version, is the hands-down winner. It just gives you the freedom to go crazy, high resolutions, complex workflows with things like ControlNet, without constantly running into those dreaded out-of-memory errors. Now, can the 46 run it? Absolutely. But you'll find yourself having to be more careful, maybe using some workarounds to get those really big, complex generations done.
All right, on to the next big challenge. Let's say you're not so much about the pictures, you're more about the words. You want to run your own large language models, or LLMs, right on your own machine. Which card is better for that?
We're seeing a very similar story here. If anything, language models are even more VRAM hungry than image models. So, if you're looking to do any kind of serious experimentation, like fine-tuning a model on your own documents or just running some of the bigger, more capable models, that 12 gigs of VRAM and the super fast bandwidth on the 3080 make it the obvious choice. The 4060? It's a fantastic, super efficient choice for inference, just running smaller, already optimized models without cranking up your power bill. Okay, we've looked at the specs, we've seen how they perform in the real world. Now it's time for the most important part, helping you choose your champion. Because really, the best card isn't about a spec sheet. It's about what you actually need. So here's a super simple 3-step way to think about it. First, just ask yourself, what am I really going to be doing? Is it the heavy lifting of training and fine-tuning? Or is it more about just running models that are already built, what we call inference? Second, what are your limitations? Think about your computer case, your power supply, your budget. And third, just match your answers to the profiles of these two cards. It's that easy.
So let's boil it all down to the final verdict. It's really this simple. Choose the RTX 3080 if you're the kind of person who needs maximum flexibility. You want to experiment, you want to fine-tune models, you want to work with huge assets and just not worry about hitting a wall. If VRAM and bandwidth are your top priorities, the 3080 is for you. On the other hand, choose the RTX 4060 if your main goal is efficiency. You want to run optimized models, you're working with a smaller power supply, or maybe heat is a concern. If you value smart, modern features in a compact, efficient package, the 4060 is absolutely the way to go.
Now, we've covered the big picture today, but if you want to get really granular, there's a ton more data and a full side-by-side spec table you can check out. Just head on over to bestgpusforai.com. Don't worry, the link is right there in the description below. And that really brings us to the final big picture question. Right now, in many cases, raw power still wins the day. But the RTX 4060, with its smart features like FP8, is really a glimpse into the future. So the question is, as the software gets smarter and better at optimizing everything, are we heading towards a future where sheer horsepower matters less than clever efficiency and intelligent design? It's something to think about for sure. Thanks so much for joining me.